Hi, everyone. My name is Sam. I work as the Director of Systems over at GitHub. I'm based out of San Francisco, moved here 3 weeks ago from England. So what is GitHub? Who is GitHub? Well, GitHub is how people build software. We're the world's largest code hosting and collaboration platform. So GitHub is around, well, it's around 382 GitHubbers. 54% of the company is remote. And we work mainly via chat, pull requests, and issues. So our team is based everywhere. I was based in England for the first 2 years of working in GitHub. And we hire people from all around the world, basically. And that allows us to have a really diverse group and set of people from all different backgrounds working with us, building what we build. So one of the things that has enabled us to build a company that's so distributed and so remote is our chatbot, Hubot. Our asynchronous way of working and our culture is enabled around chat and automating and using cultural tools through chat via Hubot. So here's me asking Hubot for an image of a unicorn. You can do all sorts of fun, silly things in chat. It enables conversations. And we do serious stuff as well. So this is Hubot bringing up a graph for us into chat so we can check response times for our database layer. Here we can see the same graph, but we overlay our deploys. So we deploy github.com via chat hundreds of times a day. We're constantly deploying. If you go to github.com right now, it's very unlikely that you'll be accessing the master version of .com. We usually have a branch out in production all the time while we're developing, while we're making changes. So you'll push a branch up to production. Like tens of CI suites run straight against that branch. And then you get Hubot reporting back the status of those CI branches, and you're ready then to branch deploy out to production. So we have a very, very fast and quick development cycle, continually iterating on our product all the time. So a little bit more about GitHub. So GitHub is 11 million people and 11 million developers working together on 29 million repositories and projects. So it's by far the largest code host on Earth. Now, I believe scale can be relative. We've been scaling web apps for a long time as an industry. And there's common practices, common things you can do. You can kind of look online you can look at talks, you can get this information about how things are done. You can't do that when you're doing the largest of something. We see novel failures and breakages around Git, code storage, all the different things that would come with that. We see those, and they're really concentrated at GitHub with what we do. So I'll tell you a little bit about the systems team, which is the team that I lead at GitHub. We're the team solving these large-scale problems around Git storage. So we're a fairly small team, but we have the Git core team, we have the Git operations team, which manage all the different services and infrastructure around hosting Git at such a large scale. And we also have the database systems team, which again, our databases, they're C++ applications running in production. So I want to share our systems philosophy. I think it's really important that every team and everyone building things and making changes has some sort of philosophy or shared values. And we've codified those, and there's something that we've kept with ourselves for years. And I'm going to take some snippets from that and share those with you. So the first is, above all else, GitHub is a Unix shop. We create programs and tools that follow the basic principles of Unix simplicity, modularity, and composability. So that's our first philosophy. That's the one thing that we look at and we refer to when we're making changes and thinking about systems at a larger scale. We also believe that there's always always easier to add complexity than it is to remove it. I think that's something that's core, and I think we've probably all noticed that throughout our careers. We're excited by new tools, but we never use them just to use them. So as mentioned earlier, you can build stuff really quickly. All these new tools, you can get into them. But we never just take new tools and just throw them into production and adopt those new technologies quickly. We experiment, but we always prefer to choose something that's proven over new. And so the core tenets of our philosophy is around simplicity. There's a general theme, and that is simplicity. We shy away from unnecessary complexity in the systems that we build. And why do we focus on that? And it's surely something everyone wants. And I think at first we assume that's something we'd strive for, but I don't actually think that's the case. as an industry, I think we build a lot of complex systems. And when I keep up with tech news or hacker news or whatever sort of industry streams that you can read from, I see that complexity is being built everywhere. And it's something that we do. Now, is that wrong? I don't think it's wrong. I think it comes down to personal choice as an industry. But it's something that we definitely try not to do. So first of all, I might as well start by sharing our stack with you and telling you what our stack looks like. So these are the main core components of the GitHub technology stack. We do use other smaller technologies, and they're dotted around for smaller projects. But the main stack that powers github.com and all the surrounding infrastructure can be seen here. So in the systems team, we do a lot of C. We focus a lot around Git. We do our automation with Ruby and a ton of shell. MySQL is our main database that powers the majority of github.com. And github.com is a Rails app. So one thing we focus on a lot is pragmatism. We think about pragmatism with all our technical choices, and we try not to reinvent the wheel when we come across new challenges. So there's a lot of philosophy talk when it comes to how we pick and we think about technologies. It's usually quite interesting to talk about as a team. So what do we get from a really, really simple stack? Why do we stay that way? First thing we get is sleep. When you use mature and stable technologies in a way that can be easily understood, and when the failure cases are known and predictable, you sleep better. You're not fixing things that you're choosing to fix. So when you choose a stack, you make a set of choices, and the more complex you make your choices, you're also choosing then to have complex failures and potentially get less sleep. So we gain predictability. Failures do happen, and it's none of our roles to try and prevent failure. It's our roles to accept that failure will happen and to ensure that when it happens, it's predictable and partial. This can be helped by choosing the correct technologies, and I just want to go into what it means to choose a good technology. So there's a phrase that comes up a lot. So what's the right tool for the job? What does it mean to pick the right tool for the job? And I think it means deciding a lot about what a technology should and shouldn't be doing. I have some examples of that coming up. So one thing you gain from choosing these types of stable and proven technologies is a lot of community knowledge. If you're looking to work around problems, if you're using a well-known and mature technology, there's a chance that other companies at a similar scale have solved these kinds of problems before, and you can just chat to them about the issues that you're seeing. And if you're keeping to a fairly common stack, there's a shared understanding there. So let's talk about databases for an example. So I was the first DBA at GitHub when I joined the company, and database is something I'm super passionate about. I really enjoy talking about them. And so there's a trend with databases at the moment in the last few years. Databases are abstracting all sorts from your application. They're doing things like they're not forcing you to have a schema. They manage failover for you. They manage your connection pooling. They do sharding, all that automated stuff. And I'd argue that that's all too much. That's way too much for your database to care about. It shouldn't be doing those things for you. If you think practically and pragmatically about what a database should be doing, it should be storing and retrieving your data quickly. Everything else your database does adds complexity and dilutes that core part of what you're using that in your stack for. So it waters down the core function of this part of your stack. So let's talk about MySQL as an example. MySQL is a 20-year-old software project that still powers the largest sites on the internet. No matter what you read online, the top 100 sites on the internet, there'll be MySQL somewhere. And if it's not, there'll be the rare cases. MySQL is absolutely everywhere. And it's by no means perfect, but it does what it's expected to do. It cares very little about the extra features that we've just discussed, and it does reliably store and retrieve data. There's plenty of bugs in MySQL. It's got its faults, but for what it's trying to do, I think it's achieved a real stable way of doing that. We can also talk about the monolith, the Ruby monolith that we run in production. So it's GitHub.com will be one of the largest Rails code bases, I imagine, and certainly one of the largest scale sites running Rails. And why do we still use Rails? And it's because when we pragmatically assess what Rails is doing for us, it's providing us immense value. So we have an amazing product team. They iterate and develop on our product really quickly. And as you saw earlier, we deploy our application hundreds of times a day. We're making small iterative changes. And the abstractions that Rails gives us gives that ability to do it. And we're in a lucky situation that we can hire very good, very experienced Rails developers that can work on making Rails more adaptable for our stack and build in that resilience, and we still get what we want from Rails. And so pragmatically making that thought, Rails serves us really well. We haven't spent the last year building microservices or nasty abstractions. We believe for GitHub that would be hugely premature. Even sites at our scale, there's so much more you can do to scale and enable that scale without just, prematurely building things like microservices. When I talk to people about microservices and really dig into why they did it, you don't get too far before you, unless they're at this massive scale or have a very specific use case, you don't get too long before they don't actually realize why they did it. It's something that I think it's a trend in the industry to start prematurely doing these kind of things. So why do humans, why do we naturally build complex systems? And I think it's to do with us, the domain we're working in and the things we're trying to do are inherently complex. Plugging computers together and building these huge stacks, these huge web applications, it's a complex task, it's different, it's difficult, it's a feat of engineering. And I think we perceive that as being the systems we build should then be inherently complicated. And I think that's wrong, and I think that's something we probably may reassure ourselves with, that building complex services and systems is fine because the domain we're working in is complex. When it comes to innovation, we innovate really quickly around our product. We develop features fast, and from conception, from idea, we can go to in production within days or weeks. And some people have been known to join GitHub and have features shipped onto github.com within the same day of joining. And the reason is because we've separated where we want to innovate. So I think as engineers, we assume we should be innovating on everything that we're doing and always rethinking our stack and our technologies. And I think that's wrong. I think you should innovate around your product and then keep your stack and what's behind your product as simple and as stable as possible. It doesn't need to get weird. It doesn't need to get fancy. It can be simple and reliable. So I want to explore what the role of these new technologies are. They're everywhere, they're coming up. We're going to hear about them a lot at these conferences. And they do have a real good place in tech. New technologies allow us to look at the problems those technologies are solving and start to think about this new approach, the way things are doing things. But it doesn't necessarily mean we have to adopt that straight away. It's fine not to just jump in and do that. Let's go back to MySQL as an example. MySQL, years ago, there was, a couple of years ago, JSON databases were everywhere. They were hitting the market. Postgres had JSON columns, all these things. MySQL's just got that in the last month, I think, with their 5.7 release. So it took them 2 years to implement this feature. But it's because they were not going to trade off stability and reliability. So it takes longer to build these things in, and it's fine to lag behind. There's really no approach you can't borrow from. Just take what the new kids are doing and apply it to your older technologies and stack. You get that approach, but then you keep what's really core to what you're doing. We've just open sourced a project this year called Brubeck. We were using statsd from Etsy, Node.js. It was written quickly, easy to iterate on, but didn't scale very far at all. So we rewrote it in C. There's a quote from a colleague of mine. The simple features of that Brubeck has no features. It's just technologies like a while loop and one thread. It's boring stuff, but it's serving all our metrics in production. Here's another example I'm going to talk about when we've removed a ton of complexity into our product, so away from our product. So some of you may know that we have an enterprise product. You can essentially have your own version of github.com inside your infrastructure. If there's some legal reasons or whatever that you can't use github.com, you can use enterprise. And that product hit the market around 2009. It took off like a rocket, and it very quickly became, a ton of technical debt, and it grew, and it's fine. The way we released and built enterprise, was developed really quickly and just built upon from there. And that's fine, that's okay that we added this complexity. It just happens, it's a natural software project. As things move along, it's fine. But suddenly, we started to get this divergence from how we develop and build software at GitHub. So the old way used to be, you'd build an OVA, a VM image out of our build process, which would take way over an hour to do. And our CI is minutes, a couple of minutes, not hours. And we have a really comprehensive test suite. but we have tons and tons of Jenkins boxes. We parallelize out all our CI, and we refuse to let that number just creep up. We always want fast CI because it's so core to how we iterate and develop. But we had this divergence for this enterprise product. And what it meant was we almost lost touch with how it was being developed. Because if you wanted to make a small change, you're not going to sit for an hour and wait for the product to this build process to then check and test what you've done. So then our releases started to get slower. We had 8 months without a release, and it just started getting slower and slower. And we decided to look at what we were doing. We had multiple repositories. I think we had 6 different applications that were being used to build this VM image. We had thousands of lines of code and hundreds of gem dependencies. We used Chef and all these industry standard layers of abstraction, and it was really DevOps. But we rewrote it. We decided it was time to rewrite and bring this project back in line with how we develop software. And we looked pragmatically about what we wanted to do. We wanted to take essentially GitHub.com's environment and package it into a VM. So maintaining and booting a VM on every small change is a huge pain. And by doing that, it meant local development was just a nightmare. So instead of that, we created a CH root and used LXC to build our environment. And boom, you've gone from hours to build to seconds, and you're able to do it locally. Essentially, you pull in the packages to the root, and there's a set of shell scripts that you'd run. And we turned GitHub.com into a VM, which is a deterministic sequence of external commands, and it's literally what shell scripts were invented to do. So we took all these abstractions that do all these extra things. Pragmatically, we just didn't need it. A small suite of shell scripts did the exact same job. So build times went from an hour to 5 minutes. You can push any single branch of GitHub.com and produce a full VM image out of that for testing. So now, rather than this divergence, so rather than releasing 100 times a day to .com and then rolling things up and releasing them like every 6 months, 8 months, if you're pushing changes, you get the feedback of how that's working in our 2 environments, production.com and enterprise, within 5 minutes. And that really changed everything for us around how we develop our enterprise software. This brings up an anecdote from like 1986. Not my anecdote, that was the year I was born, actually. But there's a guy called Donald Knuth, I think, was asked to write a program for a magazine. And that's how people shared software back then and talked about software in a magazine. And it was to count words in another application. And he wrote a 10-page application, nicely abstracted, purpose-built data structures for doing all this kind of counting and sorting. And there was a guy called Doug McElroy who was asked to review that code. And what he came back with was a 6-line shell script that accomplished exactly the same thing. And I thought that was a really interesting, I think from that point there was, again, another divergence around complexity and pragmatism. And I think that's a really interesting anecdote, and that's something that I think back to. And it's maybe not just, taking the pragmatic in smaller steps using simpler technologies can be the way sometimes. So yeah, we talked about iteration. Bringing enterprise back in allowed us to iterate a lot faster over what we're doing and make these changes. And so we iterate, we quickly, and it allows us to kind of get what we need. And really, I want this question that we have on screen now about strengthening our foundations or rebuilding them. That's something that we think about a lot, and I think about a lot, and I think it's something as an industry we could think about a lot more. Are we building upon the years of work of the people before us and making it better, taking on new approaches? As more people from different backgrounds come to technology and start looking things in a different way, are we basically wiping the slate clean every time that change happens? Or are we, like other industries and crafts, going to build upon the knowledge that we have and keep going, rather than disrupt every technology stack and try and change stuff? So that's something I think we could all take and learn. So I'm going to go to questions in a second, and the last slide is probably where most speakers will encourage you to follow them on Twitter and do that. I'm going to tell you not to follow me on Twitter. I'm going to ask you to follow these people instead. You've probably got enough white guys in your Twitter stream talking about various different things. And these are people who are talking about social issues and technology, and I think that's a really important view for us. So I'd ask you to follow them instead of me. And I'd also then like to open up the floor for questions, if anyone has any.
While you're building up the courage, maybe I'll ask a question, if that's okay. I really liked how you focused on getting like a change through CI and deployed really fast. But I think a lot of that comes down to the tooling involved.
Yeah.
Correct me if I'm wrong. And so in a company where I haven't developed that tooling, where would you rank the importance of developing that tooling? Would you, like, versus other decisions I'm going to spend my time and money on?
I think it's critically important. I think when you're developing software, you need to think about how you're developing software as much as what you're actually developing. What's your production line? How can you change that? So I think it was in the 80s, the American car market was destroyed by the Japanese car manufacturers. And in part, that was the reason for that is how the Japanese approached making cars. You could stop the line at any moment and start, if the process was getting slower or there was a better way of doing it. So they were actually thinking about the process of making cars, not just the cars they made. And I think that was a really powerful thing for them to actually do. So we very much take on the task of thinking about how software is built as well as what we're building. Hi.
Could you talk somewhat about your experience seeing Git scale out to a large distributed scale?
Yeah, absolutely. It's a difficult task. It's not easy. We have this colossal amount of storage to store all this stuff, and Git itself wasn't built to serve out at our type of scale. So we have core maintainers that work with us. A lot of our performance improvements we backport out into the open source community. We've done a lot to make Git more performant, but we've also had to build a lot of tooling around it. So we have Git-aware proxies, so when you push, it's then proxied out to the right server. We have rate limiters, so Git can check if you're consuming too much resources on a specific file server host and reduce concurrency and to cache concurrency. So yeah, it's an ever-going challenge. We've actually got some really interesting projects in the pipeline right now around Git and our long-term dedication to storing Git. So yeah, I would say it's a challenge, but it's something certainly more interesting. And if you're interested in following along, definitely watch our engineering blog, githubengineering.com, and we share more and more about how we're doing that as it goes. So yeah.
Thank you.
Hi.
Hey, is there a iterative approach towards simplicity, or is it always the monolithic rewrite that gets you there? Is there like a heuristic or a rule of thumb that you tend to follow?
Yeah, I definitely think there is an iterative approach. And actually, I think iteration itself is an approach towards simplicity. You can take, rather than trying to guess ahead of what you're trying to do, take the smallest logical thing that you can do and then iterate upon it as the need comes. I think one of the approaches as well is just iterating on your philosophy around how you build things. Discard, the ideas around technology that no longer serve you and iterate on that approach going forward. So absolutely, I think if you've got something terribly complex right now, you may need to break that out and start adding simplicity. But it's quite an extreme case to have to do a rewrite. But we got into that situation where we'd made it like a necessity.
Thanks.
Thanks.
Hi. You talked about your tech stack and keeping things simple in that stack.
Yeah.
Can you talk a little bit about the process that you go through as a team when an engineer wants to introduce a new piece of technology? How do you vet, is it in the spirit of keeping it simple, or is it the right tool, or is it unneeded complexity?
Yeah, absolutely. So it's very much a discussion. We talk about the exact need that technology is going to provide, and then reflect on what we've already got in production, and if that can be changed. We then think about who else is using this technology, how soon it arrived, and how soon it was developed, and whether it just it goes against some of those core philosophy principles that we have around technology. And sometimes it can turn into a real debate. Some people, sometimes we maybe even try it out and see if that approach can be replicated in a different way for what we're using. But we have a form of tech leadership. People, we have tech leads that have worked at GitHub for quite a while and have seen various different failure cases, and they can talk with experience about why we're not using certain technologies. But it very much becomes case by case, applying pragmatism to actually what this technology is going to do, and then assessing it as we go.